The two types of waves generally are longitudinal wave and transverse wave. Now, longitudinal wave. In these waves, the individual particles of the medium in a direction parallel to the direction of propagation of the disturbance. Okay, in longitudinal wave, the particles of the medium move move in a direction parallel to the direction of the propagation of the disturbance. Like this it is okay, like this it is move, it is here. So like this move. Okay. So this is the direction of movement. So it moves like this, it is here. The wave, the move like this. The particles are the movement of the particles. Okay, the movement of the particles are in the direction parallel to the propagation of wave. The particles do not move from one place to another, but they simply oscillate back and forth. They oscillate back and forth in the same position, about the position of rest. And this is exactly how a sound wave propagates. Hence, sound waves are longitudinal waves. Means the sound, okay, when the particles of the medium, when the particles of the medium, okay, vibrate in the direction parallel to the propagation of wave, then these waves are known as longitudinal waves. Now there is also another type of wave called a transverse wave. Okay, in a transverse wave, particles do not oscillate along the line of wave propagation but oscillate up and down about their mean position as the wave travels. You know, they oscillate like this, like this. Okay, this is the movement of the wave. Suppose this is the movement of the wave. So the particles wave like this, it is like this. So this is the mean position. This is the mean position. So move, the wave moves up and down like this. It is oscillate like this, like this. Okay. So perpendicular to the direction of the wave. The particles in transverse wave, the particles vibrate or oscillate perpendicular to the direction of the wave about their mean position as the wave travels. Okay, thus a transverse wave is the one in which the individual particle of the medium move about their mean position in a direction perpendicular to the direction of the wave propagation. Okay. Light is also a transverse wave. Light. Okay, light is also a transverse wave, but for light, the oscillations are not okay of the medium particles of their pressure or density. Means light does not require any material medium to propagate. Light is a transverse wave. Light is a transverse wave, but it does not require any material movement, any material, okay, medium for propagation. Therefore, light is not a mechanical wave. Right? Now I will talk about characteristics of a sound wave. Characteristics of a sound wave. So, a sound wave can be described by three important characteristics. So they are frequency, number two amplitude, and number three speed. Now So frequency is the number of oscillations made per second, or you can say number of oscillations made in 1 second is called the frequency of the wave. Okay, number of oscillations or the number of vibrations made in 1 second is called the frequency of the wave. Now amplitude. Amplitude is the maximum displacement of a particle from its mean position. Okay, maximum displacement of a particle from its mean position, that is called amplitude. And the speed is the distance traveled by the time taken. So these are the three characteristics of a sound wave. Okay, there can be one more characteristic, so that is the wavelength. Wavelength. So what is wavelength? So wavelength is a distance. Wavelength is a distance between two consecutive compressions or between two consecutive rarefactions. Okay, it's okay. Between two consecutive compressions or between two consecutive rarefactions. And the wavelength is usually represented by a letter lambda, and its SI unit is meter. The SI unit of frequency is Hertz, 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 and the symbol is H and small z, Hertz.